Then let's move to the next presentation. So next presenter will be Professor Rahim Tafazolli. Let me introduce him briefly. He is a professor of electronic engineering and also mobile and satellite communications. And he is the director of Institute of Communication System, ICS. And he is director of founder of 5G Innovation Center, 5G IC, and also 6G IC at the University of Surrey. So he has been a technical and strategical advisor to many mobile companies and recently served as a member of TCMC task force on diversification of telecom equipment providers ecosystem. He's a fellow of Royal Academy of Engineering, fellow of IT and WWRF. So he will make a presentation on the road to 6G research strategy. Let's welcome Professor Rahim Tafazolli.
Thank you very much, and good afternoon, everybody. I hope you can see my screen.
Yes, we can see you.
Okay,
good morning.
Very good. I would like to share with you briefly about 5G and 6G Innovation Center in ICS at the University of Surrey, and more specifically share with you the vision of the 6G that we have established with our industrial partners and which maps the research and innovation for the next 10 years. First of all, about our institute, we work on terrestrial mobile system, Wi-Fi, satellite communication, broadcasting, Internet of Things, connected vehicles, and our research, and we are working on the future Internet, architecture and protocols. Our research is from fundamental theory and some of it on the experimental research. Our mission, because we work very closely with industry, is to show industry what is the art of possibilities, how much we can push the technology barrier to the limit. And our industry partners will decide what needs to be done as part of the standards. And 5G Innovation Center was the world's first academic innovation center on 5G. We established that in 2012. And we actually won the Royal Academy of Engineering prize in 2021 for Best Industry Academia Collaboration. As I said, our team is the largest academic institute in Europe, and we work on all aspects of the wireless communication, from satellite to terrestrial, to the core network, service platform, to signal processing, antenna, and the testbed. We started 6G research in 2019, and we officially launched the 6G Innovation Center vision and strategy last November in 2020. And we have a large testbed of 5G, 4G on campus, and it is end-to-end testbed with more than 77 cells of 4G and 5G, indoor and outdoor, which allows us to do all sorts of experimental research and evaluate the performance end-to-end. So what is next for us beyond 5G? For us, we came up to say that we need to think differently about 6G. We need to consider the environmental challenges, societal challenges, as well as industry challenges and economy. How we can do that? We need to focus on ultra energy efficiency. Ultra energy efficiency doesn't mean 10%, 20%, 30%. We are talking about 80, 90% energy efficiency. Privacy and trust. And we need to overcome and solve in 6G the digital divide, especially on the broadband connectivity. We need to look at all the research we are doing with the full understanding of the 5G and 5G evolution into 5G advanced and release 18, 17, and could be 19. We will start with a clear use case, with a clear business case, so the industry can make money out of that. So what we are going to do, we are working on 4D video, because 5G enabled 3D video and 4D video, which I will explain later on. We call it teleportation. I think Facebook call it metaverse now, recently, but we talked about this in 2015. By my talk, I gave a TED talk and say how we can do teleportation. We work on intelligent surfaces. We work on sensing and sensing network. And we believe that future 6G has to be a network of networks, which I will explain later. So Thomas gave a good overview of 1G to 6G, but I would say that 5G was differentiated from previous generation because by automation. 5G is communication and automation. We believe that 6G will be communication and sensing. And looking at the higher capacity, more capacity, social inclusion, environment sustainability, and industry productivity. Why do we need a new generation? Because we need to design the radio access network, which is about 60% of energy consumption, by design, energy efficiency by design. We need to look at the new radio access network architectures with massive MIMO, with the cell-free, with intelligent surfaces. I will come and discuss that. And what is different in 6G to 5G? We want to bring in time and frequency synchronization. And that time and frequency synchronization will provide interactivity in the virtual and physical world. And core network needs to change to provide that interactivity. I will talk about time synchronization and frequency synchronization later on. First of all, massive and ultra energy efficiency system. As Thomas said, we are looking at and researching on reconfigurable, reflecting, as well as transmitting intelligent surfaces to provide energy efficient coverage outdoor to outdoor, outdoor to indoor, and indoor to indoors system. We actually built these reconfigurable intelligent surfaces, and we demonstrated this last year. We have on the right, we have static configuration where the reflection angle is fixed and is not dynamically changing. And we have on the left more dynamic, where the reflective antenna angle is dynamically changing and intelligently changing. I want to share some of the specification of this. We focused this on the 3.5 gigahertz, and the thickness of this is about 3 millimeter, 11,000 cells, and provide 45 minus plus degree reflection. And the gain on the reflection, we got 20 dB. The bandwidth is quite large, 400 megahertz, And more interesting, we provide 20 dB gain with 0 input power. On the dynamic one, again, we measured 17 dB gain, and the energy input that is required in the box here, it says ICS, is mainly electronic to intelligently move the reflected beam. So there is no RF chain, it is not antenna element, so there is hardly any power consuming elements in this architecture. And we are researching on this even more into transmittive, not only reflective, but also transmittive intelligence surfaces, which is transparent. We are looking at the new material to make it transparent so we can print them on the windows and the glasses, and we can print them on the buildings, inside and outside the buildings. To overcome the digital divide, economically, we believe that satellite communication plays an important role and the role is complementary. It is not competing. And the research we are doing is to provide direct satellite to UE connection. As you know, the satellite is power limited. And we are looking at the advanced techniques to enable both direction broadband connectivity to pocket-sized UE. So we believe that future is integration between communication and sensing, is a network of networks, and there are 3 major elements in this network of networks. Satellite communication, which is direct to UE, plus sensing. Cellular, public and non-public networks, plus sensing. And personal area network sensing. I will talk about sensing a little bit more. Many people talk about sensing, but I want to give you some examples of what sensing information is important. Sensing can be divided into 2 areas. One is the network sensing, another one is the personal area sensing. Sensing itself, it provides an eye into the communication. It helps all the layers of the protocol stack, from physical layer, I think Thomas mentioned about multipath, for example, and all the way to the network layer, MAC layer. And it provides energy efficiency. So if you have one sensing, could be like camera, if we have a good picture of this traffic congestion in the connected vehicle, we can manage the interference better. If we have a camera, when we know where the people are moving, then we can do beam steering. Electromagnetic sensing is intelligent, reflecting, and transmittive surfaces. So we sense the electromagnetic radiation and we direct it to the direction that it is important. Another area of the sensing for the network sensing is using camera, LiDAR, or radar. For example, this vehicle is moving and entering a tunnel. So the channel characteristics will change fundamentally when you go from outside the tunnel inside the tunnel. But if the network knows that the car is moving into tunnels, then it will help with the channel equalization better. So it will help with the energy efficiency, with the signal processing, with the quality of the system. Then the second level of the sensing is the personal user context sensing in terms of air quality, proximity detection, light, noise, pollution detection, as well as image estimation and activity detection. And we are looking at sub-terahertz all the way to 300 gigahertz for image estimation and testing. And we go one further. We are looking at other senses, human senses. We're trying to capture, in addition to video and audio, we want to capture and transmit touch, taste, and smell. To the extent that we believe that in the future, we can even sense state of mind of a person. So there are many challenges in sensing. We talk about terahertz with terahertz components, transmitter, receiver, wearable networking, and as well as wearable materials, integration of sensing information in communication, and we need to have a standardized data model and a semantic description of the sensing data to be integrated in the network. And obviously there is all computing, edge computing, and etc. But privacy preserving and bilateral authentication of protocols between all these nodes and the sensing nodes are very important. And the AI plays a very important role. When we do high quality time synchronization, we are actually enabling teleportation as well. I have to say that latency is different from synchronization. Latency is brought about low latency by 5G. 6G will bring, in addition to low latency, will bring time and frequency synchronization. And if we have a low synchronization together with latency, all the use cases for 5G become more intelligent and more interactive. It enables driverless and cooperative driving, and all the way to teleportation. For the time, I'm just going to speed up a little bit. Look at this person was teleported to our building and using 5G. So what we are doing here, we are only transmitting two of the human senses, which is hearing and seeing. So if we add other senses together with the touch, smell, and taste, together with time synchronization, I could shake hands with this person. In 5G, I'm not capable to shake hands with this person. For example, we could walk with each other. We could interact with each other. So the teleportation, or something that Facebook is referring to it now, is metaverse, is the differentiation that from the use case 6G will bring about. There is lots of research issue we are doing. I'm not going to go into details of this, but we believe that coverage to overcome digital divide, I'll come to this one, coverage to overcome divide using the intelligent surfaces, satellite communication, synchronization for interactivity, and high for interactive health, e-health, robotics, image and sensing provides geolocation, and all of this will enable interactivity between virtual and physical world. Thank you very much. There is more detail in our 6GIZ white paper that it is on our website. You can download it and you can read it. Thanks very much.
So you highlighted intelligent surface or reconfigurable reflecting transmitting surfaces in terms of energy saving. I think it's very important indication, and also you highlighted non-terrestrial network. So we will have a following sessions focusing on the non-terrestrial network also. So we will have a very good presentation today. So it was very helpful. Thank you very much again, Professor Tafazolli. It was very early in the morning in your place, but it was very helpful to us. Thank you.